Hi, in this video, I will help you choose the appropriate data analysis that you can use for your research using descriptive statistics. This video will discuss frequency and percentage, measures of central tendency or location, and measures of variability or spread. These do not actually test any hypothesis. Descriptive statistics are brief descriptive coefficients that summarize a given dataset, which can be either a representation of the entire population or a sample of it. Descriptive statistics are very important because if we simply presented our raw data, it would be hard to visualize what the data is showing, especially if there is a lot of it. Descriptive statistics, therefore, enables us to present the data in a more meaningful way, which allows simpler interpretation of the data. We will be discussing some of the most commonly used descriptive statistics in quantitative research: frequency and percentage table, measure of central tendency, and measure of variability. Let's start with frequency and percentage tables. This displays counts and percentages for each distinct value found in a variable, normally a categorical variable. Frequencies are the number of times each score occurs in the respective dataset, whereas percentage is a number or ratio that represents a fraction of 100. Frequency and percentage table is normally used to describe nominal variable such as sex, religion, place of birth, etc. In creating frequency and percentage table, all you need to do is to identify the possible data associated with your variable. For example, sex, which data are either male or female, and count how many times these data occurred in your dataset. For frequency, then divide these numbers by the sample size and multiply by 100 for percentage. Here are some examples wherein you can use frequency and percentage table to answer research questions or achieve research objectives. A researcher would like to know what religion his respondents belong to. A high school teacher would like to know how many of her students find her subject difficult or not. A research student would like to describe the grade level of his respondents. And a reporter would like to know whether people agree or disagree with the anti-terror bill. The next is measure of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are sometimes called measure of central location. They are also classed as summary statistics. While there are 3 measures of central tendencies, in this video, we will discuss only the 2, the arithmetic mean and median. The first measure of central tendency is the arithmetic mean. This is a mathematical representation of the typical value of a series of numbers, computed as the sum of all the numbers in the series divided by the count of all numbers in the series. The arithmetic mean is sometimes referred to as the average or simply as the mean. There are several assumptions that you need to satisfy before you can use the arithmetic mean. If at least one of the assumptions are not satisfied, then you cannot use it. Listed below are the assumptions. The measurement scale of the variable is at least interval. The data should be approximately normally distributed. And the data should not contain significant outliers. The first assumption can be satisfied if your research instrument gives an interval or ratio data. The second assumption can be checked using normal QQ plot, histogram, or other statistical tools. Finally, the third assumption can be checked using box plots. You cannot use arithmetic mean for nominal or ordinal values because adding the data associated with this kind of variables does not make sense. For example, consider the educational attainment of a certain sample group. This variable is considered as an ordinal level variable. If we try to describe them using arithmetic mean, the value is 2.4. What does a 2.4 educational attainment mean? A second-year college student? Basically, it is not clear to us what 2.4 educational attainment mean. Also, adding college graduate, college level, college level, college level, and college graduate does not make sense at all. In addition, arithmetic mean is quite sensitive to outliers. If there exists at least one outlier in the data, the arithmetic mean does not describe the entire data well. For example, consider the wages of 10 staffs at a factory below. Notice that staff 9 and 10 have significantly large salary compared to the other 8. We may consider them as outliers. If we try to compute the mean salary of the sample, we get 30,700 pesos. Clearly, this value does not represent the sample effectively since 8 of the samples are below it, whereas 2 of them are above the average. Here are some examples wherein you can use mean to answer research questions or achieve research objectives. You want to describe the weight of your family and you found out that the data is normally distributed. You want to describe the daily allowance of your classmates and you assume that it is normally distributed. And you want to summarize your grades in all subjects for the first quarter and you found out that your grades are normally distributed. The next central tendency that we will discuss is the median. This is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. The only assumption that you need to satisfy before you can use median is that the variable should be at least ordinal. In fact, if your data is either not normally distributed or contains significant outliers, you must use median instead of mean. Definitely, you cannot use median for nominal variables because they do not carry any magnitude. Here are some examples wherein you can use median to answer research questions or achieve research objectives. A doctor wants to describe the pain experience by his patient, as measured as not painful, slightly painful, painful, and very painful. A researcher would like to summarize the weight of his respondents, but the data is not normally distributed. And a manager would like to summarize the monthly salary of his employees, but she found out that it contains significant outliers. Finally, the measure of variability. A measure of variability, sometimes also called a measure of dispersion or measure of spread, is used to describe the variability in a sample or population. It is usually used in conjunction with a measure of central tendency, such as the mean or median, to provide an overall description of a set of data. A measure of variability gives us an idea of how well the mean, for example, represents the data. If the spread of values in the dataset is large, the mean is not as representative of the data as if the spread of the data is small. This is because a large spread indicates that there are probably large differences between individual scores. Additionally, in research, it is often seen as positive if there is little variation in each data group, as it indicates that the respondents are similar. In this video, we will discuss the standard deviation and the interquartile range. The first measure of variability is the standard deviation. The standard deviation is a statistic that measures the dispersion of a dataset relative to its mean and is calculated as the square root of the variance. Standard deviation is used when the arithmetic mean is used to calculate central tendency. If the data points are further from the mean, there is a higher deviation within the dataset. Thus, the more spread out the data, the higher the standard deviation. Another measure of variability is the interquartile range. The interquartile range describes the difference between the third quartile and the first quartile, telling us about the range of the middle half of the scores in the distribution. The interquartile range is often reported along with the median as the best choice of measure of spread and central tendency, respectively, when dealing with skewed and/or data with outliers. Similar to standard deviation, the variation is high if the interquartile range is high. In summary, the table below summarizes what statistical tool should you use to describe your dataset. If you have a nominal variable, you may use frequency and percentage table to describe your data. If you have ordinal variable, you may use median and interquartile range, or frequency and percentage table. If you have interval or ratio variable, but not normally distributed, contains outliers, or both, you may use median and interquartile range. Finally, if you have interval or ratio variable and is normally distributed, you may use mean and standard deviation. While there are other descriptive statistics that you can use to describe your data, these are enough to give you an idea about your respondents or your unit of analysis. That's it for our video. Thank you very much and have a good day.